Okay, so now that we've been introduced to sine and cosine graphs, let's take a look at tangent. All right, so tangent is a little different. It is still periodic, but it looks not like a wave. Okay, so tangent, remember, is y over x. So we have to do a little bit of arithmetic sometimes to get this. Well, let's start at 0 again here. Y over x, we're looking right here. So that would be 0 over 1, which would be 0. So it starts off pretty harmless. I'm going to put a dot right there. Okay, now I'm going to go to this value right here, pi over 4, because it's going to be a little easier. We have square root of 2 over 2 divided by square root of 2 over 2. So that would be just 1, right? Anything divided by itself is 1. So at pi over 4, which is just 1 square here, we're at 1. Okay, now if we go here, we do y over x, we're going to get 1 over 0. Now remember, you can't divide by 0, so this is undefined. So we get something called an asymptote line. Remember, this is an asymptote line, if you remember from previous classes, maybe you don't. This is where you have an undefined position. So I'm going to draw a line at pi over 2. Okay, and this is a line that the graph can never touch. So what I'm going to do now is make that dashed. So I'm going to do that with my eraser. So I have a dashed line, and that this graph can't touch, will never reach. So that is the undefined line, and that occurs at, in this case, pi over 2. So since we run into that situation, I'm actually now going to go, make my eraser a little bit bigger. I'm going to go back the other way now. So I'm going to look at my unit circle here and just kind of go in the reverse order. So now we're going to go this way. So if I go to negative pi over 4, that's going to be right here. And I would have negative square root of 2 over 2 divided by square root of 2 over 2. So that'd be negative 1. Okay, so at negative pi over 4, I'm at negative 1. Okay, so now if I go to negative pi over 2, I have negative 1 over 0, which is another undefined line. So here at negative pi over 2, I would have another asymptote line. So actually, let's just do this. I'm going to copy that. Oh, that didn't quite work, huh? All right, well, we tried. So what I'm going to do is do that same thing. Okay, and then okay, so I have this again. Now what happens with this graph is it goes up, but it gets really close, but never really touches. And then same thing down here. So I kind of get this sort of weird curved shape in between those asymptote lines. Now, if I continue this way, so let's say now let's go to just see what happens here. So now we go here at 3 pi over 4, we're at negative 1 again, okay? So let's make a dot. Now if I go to pi, I would be back to 0, right? 0 divided by negative 1. If I go here, I'm going to be at a negative square root of 2 over 2 divided by negative square root of 2 over 2 is going to give me positive 1. Now if I go back here, I'm going to get undefined again. Okay, so you can see that this now continues to repeat. Here's my asymptote line. Ooh, messed that up a bit. Okay. And when you do your asymptote lines, make it dashed. These are lines you can't really see, but it makes it easier to draw them in. So then we're going to put them, we're going to dash them. Okay, and now this just repeats either way. So I'm on green already, so this would be -1, there, there, and I would be able to see this much. And if I go the other way, I'd have this situation as well. So notice every 4 squares, I have an asymptote line. Okay, draw that in there. Gets close but doesn't touch. It will get infinitesimally close but never quite reach. Oh, I need to try that one again. All right, so this is what tangent looks like. All right, so you'll notice, as we said, quite a bit different than the other two sine and cosine graphs. What's my amplitude? Remember, how high does this go or how low? Well, it doesn't wave, so that's we can't really tell. It just keeps going up to infinity or down to negative infinity. So the amplitude doesn't fit our definition of amplitude in our traditional sense, so we're going to say it's undefined. The period, how long does this take to repeat? Well, notice this distance right here. How long is that? Because now it repeats after that. Well, you can see it's a half pi here and a negative half pi there, so that's a total of 1 pi. The period then is pi, right? Now, one thing to note is even though the period is pi, the graph is sort of split in between. Notice you can see half of it is on this side and half of it is on this side of the y-axis. So you can see a half pi from here and a half pi this distance here. So that pi is split sort of in half. And the asymptotes occur at here and here. So these are odd multiples of pi over 2. You can see 1 pi over 2, 3 pi over 2, 5 pi over 2. So that's what I'm going to write, odd multiples of pi over 2. That's not something necessarily you need to remember, but it's just kind of helpful as you're kind of thinking about the original graph. Okay, so now let's try to take a look at some different things. Now, changing the amplitude in the period works the same. The amplitude will, when you put an A in here, that will impact the graph. It just won't show up when you write here. It's still going to be undefined. So that we'll keep in mind. Now, the period for tangent is pi. So when we divide it by our b, we're going to do pi divided by b, not 2 pi divided by b like the other two, sine and cosine. So keep that in mind as well. Okay. So here, let's take a look. So now notice the amplitude has changed. Well, the A has changed, but the amplitude hasn't. It's still going to be undefined, but that 2 will still have an impact on my graph, and you'll see what I mean here in a second. The period, this one hasn't changed. We don't have a B here, so we're good. Okay, now, that means my period is still going to be, I guess I should write that, pi then, okay? All right. So I already know, because the period hasn't changed, I'm going to put some asymptote lines. You can use whatever color you like. I kind of like to stick to bright colors here. So my period hasn't changed, so that means these will stay in the same spot. And I'm just going to put those in there every 4 squares, because that represents 1 pi. Okay, and use my trusty eraser here. Okay. And here we go. Now, when I do the 2 here, I know that tangent starts at 0, and then it's normally right here at 1 at pi over 4. But that 2, even though it doesn't change my amplitude, it does change that next thing. You're multiplying that 1 by 2 now, so that's going to be there at 2, and this one will be at -2. So this does have an impact. You need to be aware of that. It doesn't change your amplitude answer over on the right. It's still going to be undefined, but it will change your graph. Okay? So now I'm going to do that. This will go to 2, -2. 2, -2. Okay. And now I'm just going to connect all these. And they still have a little bit of a curve, so you want to kind of try to indicate that as much as possible, even though it doesn't. Don't draw a straight line. It should curve a little, and this curve is just not quite as pronounced as on our other ones. Now, if you were graphing this on your graphing calculator, all you would see is the stuff in purple. Okay, so there we go, and that is what that A value will do to your tangent graph. Okay, how about a B value and changing the period a little bit? So here I know, well, let's just stick, this is going to be undefined. We know that already. The period, now I need to figure this out, right? It's going to be pi divided by 1/3. So remember, it's pi, not 2 pi. So multiply by the reciprocal. That'll be 3 over 1. So this is going to be 3 pi. Okay. Now I like to start with my asymptotes because if I can figure those out, I'm pretty good to go. Now my period is 3 pi. But remember, let's go back to the original graph of tangent. Here is my period. Oops. Here's my period. Okay, but the period is split in half over the y-axis. So I just want to split 3 pi in half with the y-axis. And then I can continue that. And that is the easiest way to graph tangent. It's a little easier to figure out once you remember that. So if I take my period is 3 pi, it says, well, I want to cut that in half. That's 1.5 pi, which is the same as 3 pi over 2. So if I have one asymptote here and one asymptote here, that's going to total 3 pi. So that's what I want to do. So I'm going to draw my line. Draw my line over here. Okay. Use my eraser. Okay, so now my amplitude, my A value hasn't changed, so let's go different color here. Okay, so I know I'm at 0 in the middle here. The amplitude, so halfway in between here, I should be at 1. So that's 6 squares, so that means 3 squares. So this would be right here, 3 pi over 4. And then halfway between these, 3 squares, right? Oops, I want to be at -1. Okay, so okay, and then 3 squares, I would see that. So really I would just see kind of this bottom part. And over here, 3 squares over, and this would be on its way up. So make sure you fill out the entire graph, not just part of it, as much as you can, as much as they give you. So there we have it. Okay, I just want to go over one more so you're getting used to what this looks like. All right, so y equals 1/2 times tangent of 2 theta. So once again, this is undefined. You can just write that right away, but keep in mind this still impacts us. Okay, and then the period would be pi divided by, in our case, this case our b value is 2, so pi over 2. Okay, so what I'm going to do is, remember, I'm going to split this in half and have the y axis split it in half. So I'm going to do, that's a half, so I'll do a fourth on each side. So what that means is I'm going to have one asymptote here and one here. That would give me my 1/2 pi. So it really means every 2 squares, I'm going to have another asymptote. So I'm going to draw that in. Ooh. Yuck. Try to do it a little better than I am. You can see I'm going to have a whole bunch of little teeny tangent graphs in here. Okay, now I'm going to take my eraser. I'm going to just cheat a little bit. Okay. All right, just wait for it. Okay, now I'm going to plot my lovely graphs. Now I know this is 0, and now it's a half, right? So I want to put a dot right there and right here. Okay, so this is going to be a little weird. I'm going to do that all the way throughout here, and then make sure I graph that as best I can. And then we have tangent. All right, so try to make these as neat as you can. I know it's a little trickier on the iPads, but it's nice to have the color options. It does look a little bit nicer to see with the colors. Okay, and that is tangent. I hope you're getting the hang of this. Next week we're gonna put all this together, and you're gonna have some assignments on this. So make sure that these make sense. All right, see ya.